So for this chapter we are going to have to learn how to balance reactions, the chemical equations. So let's go over some basics real quick. Everything that's on the left side is called a reactant. Everything on the right side is called a product, right? So you have your reactants becoming or reacting to become a product, right? And the things that are on the bottom here are called subscripts. So we're already familiar with that. And any number that goes in front, a full-size number, those are coefficients. So what our goal here is to have the same number of, let's say, irons on the left as we have on the right, the same number of potassiums on the left as we do on the right. So that's our goal. So we'll notice another thing. I'm going to actually get a little pencil, something with pretty colors on it. And what I'd like you to notice is that sulfate, which we all know is SO4, sulfate is the same on this side as he is on the right side, right? So sulfate doesn't change. So why don't we treat him as a package deal, like as a together piece, right? What else doesn't change? OH, right? He's still the same on the left as he is on the right. Blurry. All right. So OH is the same on the left as he is on the right. So why don't we treat him like a package deal, right? So let's start with the left. So you guys will notice that what I like to do is I like to change something, and then I see what I adjusted, and I run over here and change it, and then I run over here and change it. So remember that these are not, we may have to change the number more than once. So it's a going back and forth and checking and back and forth and checking. So picture like you're running with a plate in your hand and you're like a waitress, okay? So how about Fe has 2 on this side? So I run over here, and what do I have to do? Put a 2 in front of here to satisfy this one, correct? Whoops, now what did I just change? The OHs. How many OHs? How many hydroxides are on this side? 6 now, so put a 6 here, right? Now what did I just change the number of? I satisfied the OHs, but now I just changed the number of the Ks. So what do I put in front of this to end up giving me 6 potassiums? A 3. I'm going to put a really skinny 3 in there, right? So now I have 6 potassiums, which I have 6 over here. Now what did I change? Sulfate, SO4, 3. Whoop, go over here. Oh wait, it's already a 3. So let's go and double check what we have. On each side, how many Fe's do I have? I have 2 on here, and Fe, I have 2. Yay. How about sulfate, SO4? I have 3 here, and SO4, I have 1 right here, but it's multiplied by 3 because of the coefficient. So my SO4s, I have 3 as well. Yay. Potassiums, I have 6. And K's I have 6, so K is 6 over here, K is 6 over here, and how many OHs on this side? 6 times that OH, so 6 OHs, and on this side I have 6 OHs. Balanced, right? So the coefficients are 1 iron sulfate, 6 potassium hydroxides, 3 potassium sulfates, and 2 iron hydroxides. So these are the balanced equations. So down here, this is one actually from your homework. This was from online. This is from your homework. So this is where we get a little tricky. You notice that oxygen doesn't just end up in one place or the other, and it's not like up here where sulfate stayed in one place and it stayed in one place over here. Oxygen did not remain intact, did it? It ended up splitting into 2 different compounds. So this is the big trick here is notice how oxygen is an even number on the left, but as of right now, oxygen is odd on the right, so we can't have that. Which one of these is making oxygen have an odd number? It's this one, water, right? So this has to be an even number. This coefficient must be even in order for us to be able to balance the oxygens. So we go in here with that in mind, and now let's go ahead and balance them. So probably the easiest one to do is I look and I see that in this compound I need to have an even number in front of the oxygen. What else is in the H2O? The H's. There's 2 here, right? On this side there's 8. So what I can do is add a 4 right here. Now the H's are satisfied, and now the oxygens are satisfied. So let's keep going and see if this 4 is going to hold up. What else do we have going on? I know that the carbons have 3 on this side, so there are going to have to be at least a 3 here, right? So now my carbons are satisfied and my hydrogens are satisfied. Let's check on oxygen. So there are 2 right here, and there is a total of 6 plus 10. So all I have to do is put a 5 right there. And now I have 3 carbons on each side, 8 hydrogens, 10 oxygens, 6 oxygens and 4 oxygens. So this one is now balanced as well. So these are probably the caliber of what I would expect you to be able to do on an exam. Nothing a lot more tricky, and you will not be expected to write the equation from a word problem. There are a couple of those on the homework, but for the exam I won't make you do that, but it's just good practice when you have the book and the internet in front of you to be able to look up those compounds. So this is the caliber of what I would give you. I'd give you this without the coefficients and expect you to put the coefficients in there. All right.